we've been now. You'll have one more test, okay? Um, Test number 3 is next week. We have to have it next week. When is the um, Easter break? When does the Easter break start? Thursday or Friday?
Thursday.
Thursday. Um,
17th is last day.
so we can have test number 3. I think after you come back from Easter break, there's only one day, right? 1 day of class.
I think we have the rest of the week, Tuesday, Wednesday. I think we have that. Yeah, Monday.
Just Monday?
I think that'll be our last week when we come back. That Tuesday to Friday. When we come back.
How long is the Easter break?
Till Monday. Thursday to Monday. Thursday, Friday, Saturday, Sunday, Monday.
Okay, so you have classes the remainder of the week.
Yes, I believe so.
So let's do this. Okay. So test number 3, we'll do it Tuesday. Okay. 2 weeks from now, which would be 04. Today is 8. We have 15, 23. I don't think you have. When are your exams starting?
Graduation, senior examinations begin Wednesday, April 24th.
And where's the last day of class?
Last day for seniors. Graduating seniors final examinations in Monday, April 29th.
No, when is the last day of class?
Everybody.
Last day of class for graduating seniors.
Sure, I want to say it's the end of the month though.
No, it cannot be end of the month.
I just have to do a quick. I don't have to hold the actual thing. Just have to do a quick. It doesn't specify.
Yeah.
I have to go to the website. Yeah, it doesn't specify.
The last day of class doesn't specify?
No, sir. Not for graduating seniors. We just say that the final exam being like 29th.
It just starts with the final exams on the 24th.
Okay. Alright, in that case, I think we'll have to do the next week itself. Next week is our only option then. Because Thursday it's starting, right? Next week, Thursday is when the Easter break starts,
Yes.
right?
Yes, sir.
We'll have to do it Tuesday. Okay. So Tuesday from a week from now, be 15?
16th.
Today is 9th, is it?
Yes.
Yeah, today is 9th.
Like this one.
Hmm?
19th, it says that Wednesday, because I won't be here Monday or Tuesday.
Where are you?
I'll be driving up to Huntsville for an interview.
Okay. When are the DBF folks returning back?
Friday.
Hmm?
I think Friday.
So you guys are going to be here, okay? All right, that's fine. So Tuesday would be test 3, okay? And test 3 would be, again, just one chapter, it will be root locus. And this will potentially replace your test 1 or test 2 grade, depending on if it is less, if best 2 out of 3, all right? All right, so what we looked at was last class, if you're looking at sketching root locus, so again we'll look at an example. Think about we'll take a bigger example today. All right. K into s plus 3, 1, 2, 4. S into s plus 1. All right. So here, the goal is what is the range of K and how does it affect the system type? Okay. So you're designing K essentially graphically. So this range of K is designed, this design is graphical, and that graphical method is the root locus. Okay. So the first thing you're going to do is what are the open loop poles and zeros? Here,
0, -1, -2. Is that 4?
s is equal to -3 is the 0.
Oh, there's some other roots.
Alright, s is equal to 0, -1, -2, -4 are the poles, open loop poles. Okay. Now, what we need to do is the closed loop poles. We're doing this, right? G of s divided by 1 plus g of s. And if you do this, you're going to get k into s plus 3 and s into s plus 1, s plus 2, s plus 4 plus k. Okay. If you simplify, this is what you're going to get. Right? So you can see that the closed loop poles are going to vary as a function of k. Alright. What we looked at last class, and this is what you all need to do. Erase this. We look at this is sigma, this is j omega, this is positive j omega, and this is negative j omega. Right? And negative 1, negative 2, negative 3. Let's just have 4. 1, 2, 3. Your first you do is you plot your first open loop poles. Okay, open loop poles are 0, right? Negative 1, negative 2, and negative 4. And you have open loop 0 is minus 3. Okay. The first thing you need to figure out is, for sketching, sigma A. Sigma A is the real axis intercept, right? So remember the formula for sigma. It's a very simple formula. Summation of finite poles minus summation of finite zeros divided by number of finite poles minus number of finite zeros. Okay. So summation of finite poles. What would this be? I'm just going to do it here. This would be minus 2, minus 1, minus 2, minus 4. It is minus 7 minus of minus 3, which is 4 divided by okay, it's 1.23. So your real axis intercept is this. And your asymptote angles, the second thing is you have to draw your asymptote angles. Okay? Theta A is equal to what? 2k plus 1 pi divided by, again, number of finite poles minus number of finite zeros. Right. So here if you look at this, this is what? 2k plus 1 pi divided by 3. Alright. you just do this, k equal to 0, theta A is what? Pi by 3. Okay. K equal to 1, theta A is equal to pi. Right? K equal to minus 1, theta A is equal to minus pi by 3. And if you keep doing this, k equal to 2, theta A is equal to 5 pi by 3. K equal to minus 2, theta A is here minus 5. So you're going to see that these three are the only angles. Okay. What is 5 pi by 3? Anybody?
What do you say?
5 pi by 3. Where will 5 pi by 3? So I'm going to draw these angles, okay, first. Asymptote. So pi by 3. This is pi by 3 is how much? 60 degrees, right? Okay. Pi is 180 degrees. Alright. And minus pi by 3 is simply minus 60. These are the three asymptotes. Alright. What is 5 pi by 3? This is pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, 5 pi by 3. 5 pi by 3 is nothing but negative pi by 3. Okay, negative pi is nothing but pi. And if you keep going, all the three angles are going to keep on repeating. Alright? So you draw this asymptotes, and this will give you your root locus. Okay, there are how many branches are there in this? Go back to your rules and figure out how many branches are there. How many branches? What are the first rules? Say number of branches is equal to
The number of 0 poles.
Poles, closed loop poles. Okay, how many closed loop poles are here?
I see 3 S's.
How did we
4 S's.
What is the order of this?
That is going to be type 0.
Order.
4. It's the first one.
It's a fourth order system. So there are 4 branches.
Question. You said it was. How do we choose the K's to use? How do I know? How do we choose what K's?
You start with 0, 1. Just integers. 0, 1, minus 1, minus 0, 2, minus 2. And then you'll get.
I thought your pole had to connect to a 0. That's what made it a branch.
How many poles are there?
There's 4 poles.
Okay, so there has to be 4 branches. Branches have not been drawn yet.
Oh.
Okay, those are the asymptotes. Alright. So the first branch, so pay attention here. The first branch is going to look like this. The second branch is going to look like this. The third branch is this. The fourth branch is this.
Could you explain the second branch?
Right, yeah. So we need to look at the fourth, not fourth, third rule. What does the third rule state? Read from the book. Anybody? I'll read from the book. Okay. Real axis segment. On the real axis, for k greater than 0, the root locus exists to the left of an odd number of, I'm going to write this. Put erase this, okay? So it says on the real axis. K greater than.
Did you explain how it would be the parentheses?
The root locus exists.
How do you do that? Is this? Let's see, I don't say. I'm thinking this, I'm trying to figure out how you just did what you just did there. Yeah. How do you do it? You don't know. I thought somebody asked.
What?
You asked him about the mention.
The one, second one.
All of them. How do you?
He's doing that right now. So this is the third bullet he's talking about.
He's telling
Okay.
us how he sketched it.
And that'll explain how he's drawing the lines.
So keep in mind what are these branches? So if you see, I'm going to mark them. Do you see 4 branches first of all?
Yes.
How do you determine where they go? Right? That is the question. Do you understand what these branches are? Do you understand what these branches are? No? Guys? You understand these branches, what these branches are? Yeah, you can say no, just tell me no. Yeah, just say that. That's okay. These branches, so when k is equal to 0, what are the poles?
0, negative 1.
That's what you see, right? When k is equal to 0, it is 0, minus 1,
Negative
minus 2, minus 4, minus 3.
When k is equal to 0,
The poles are that, right?
I thought the whole thing was 0 and now.
Don't worry about the numerator, okay? Just focus on the denominator for now. You see the poles when k is equal to 0?
Yes.
When you start increasing k, all right, this 0, the 0 will go from 0 will start increasing. You see it?
Wait, say that one more time.
This pole, when you start increasing k,
Mm-hmm.
this is what is the order of, what is the system type here?
It's a type 1. Is that what you're talking about? Like,
Is it type 1?
Okay, go to 0.
or no, it'd be type 0 if it was.
Yes. When k goes to 0, what is the system type?
When k goes to 0, if k was equal to 0.
If K is not in there, if K is not in the denominator, it's probably type 1.
Right. If k is there in the denominator, then
Type 0.
type 0. Okay. So for all practical purposes, this is a type 0 system because k will.
So, if K is in the denominator, then if K is in the denominator, then it's a type 0 system. Is that fact?
No.
Mm.
It's he's
If
saying
K
that
is 0,
okay, if you can factor out an s from the denominator, it's a type 1. If you can't factor out an s, so if you look at this, so it'd be s plus k times s plus 1 times s plus 2 times s plus 4. That's a type 0 because you can't factor out an s. If you were to FOIL that, you'd have a number that isn't multiplied by an s.
Okay. You got it? So this is a type 0 system for all practical purposes. Okay. When you start substituting value for k, all right. When you start k equal to 0, the poles are 0, minus 1, minus 2, minus 4. All right. When you start substituting k is equal to 1, what will the 4 pole become? It starts going in that direction. Does that make sense? Julian, put your cell phone down. You can read later. All right. You see it going that way. You don't see it? Do you see the roots changing if I substitute k? You don't see it?
From that picture, no.
Hmm?
I don't see it from the picture.
From the equation, do you see the poles changing if I start substituting value for k?
The poles.
The roots of this polynomial, do you see it changing when I substitute value for k?
Yeah, if it's an integer.
Integer, non-integer, will it change? Will the
So are you
No.
talking about if you were as k gets a value
Hmm.
and you FOIL it, that's when the roots would start changing.
K's not even part of the 4, bro.
No. So it'd be, yes it is, because it's s plus k times s plus 1, or,
How's it part of the 4? Tell me that.
wait, sorry, no, you're right.
Okay, so you're saying that's showing.
k is part of pole. How is it not
I said
understand?
4. I said it's not part of the 4, so you're not multiplying by it.
But it makes sense, because it's like, okay, so if you were to FOIL s times s plus 1 times s plus 2 times s plus 4, and
Look
then
at this simple.
divide
What
it
are
up.
the
Bro, you're not going to multiply anything by K.
I know that.
what are the roots of this
0
when
and
k equal to
-1.
0?
If k equals 0, then it'd be 0 and -1.
Okay.
Okay.
S is equal to 0 and 1.
So that's just showing us how the poles change as K.
What is the root? What are roots of this? Is it still 0 and 1?
No, so you do it'd be s squared s plus 2, s squared plus s plus 2, and then
S square plus S plus
2, and it'd be
1.
Oh, sorry, it looks like a 2 from here, but it would be.
Okay.
That's not how you write it, but I mean, it's just saying K is equal to.
But when you break that apart, the roots would change. So yes.
So you see the roots changing, right?
Yes, sir.
You see S is equal to what? Minus 1 plus or minus square root of 1 minus 4
1 over 2.
Oh, I see.
Okay. You see this becomes complex.
Yes, sir.
Okay. This becomes what? Minus 1.
Plus 3i.
Yeah. 1 over 2.
Plus 3i.
plus or minus
Three
root 3 over 2 I. You see it?
Now I see what you're saying. Sorry.
So,
I didn't make it.
so you see that one where it starts at -2 and goes to -3. So
First tell me, hang on. First tell me you see this, right?
Mhm.
You see how K is affecting the poles?
Yeah.
So instead of what does K, what does this system, what do the poles determine of a system? Stability. Correct. As you increase K, you see that the system is becoming, at this point, at this K, the system becomes unstable. You see it?
I don't even know what K is.
We'll figure that out. We'll figure that K out. But when you keep doing this, okay, here what I'm telling you is, you could substitute, you could create a table and do this plot, or you could do this graphically. You could have done this, and I did this in class. We did this in class, okay? You have K, S1, S2, S3, S4. Okay, K equal to 0. What is S1? 0, 1, 2, 4. What is 1? Will be, what will this 0 become? It will go, it will become greater, it will not become 1. This 0, what is the most real value of this? This is 0 point something. Okay, this -1 becomes less than -1. You see it, how it is going, what direction it is going.
Yes, sir.
Okay, it is -0.9 something. This -2 becomes greater, -2 point something. This -4 becomes -4 point something. You see that direction it is going. Okay, if you do 2, this again becomes 0 point something. It becomes less and less. So this is less, this is less. This is greater. It keeps on increasing. Okay, from this to this, this to this. Here it decreases. You can see that. It is decreasing. Here it is increasing.
I'm just confused at one.
Huh?
Can that -2 pole not go past -3? Like, are there no solutions?
Yeah, that's what I'm coming there.
Okay.
So first you understand this, how the K is affecting. Here, keep in mind, we did this. This is control, okay? By tuning your this thing, control K gain. You did this in your lab experiment as well. You are tuning your K. You remember tuning your K? You don't remember tuning your K?
The game?
Yeah. So you are tuning your K, alright? And see how it is affecting. Mathematically, I'm showing you how it is affecting. At some point of K, the system becomes unstable. Okay? What is one of the roots when K is infinity? Look here.
And it's gonna go to 0.
Hmm?
Oh no, it's gonna.
Look here. One is one of the roots, one of the poles when K is equal to infinity.
Now you're not looking at the equation. What about the equation?
When K is equal to infinity, this -2 becomes -3.
That's what's going on.
You see it? This is K 0 to infinity. This is K 0 to infinity. This is K 0 to infinity. All the poles are changing. Okay, so when k is equal to infinity, all these are changing. So you don't know what is this pole, what will this pole be? You don't know what, you know what this pole will be. This pole will be minus 3. This will be, we don't know what this will be. But at some point, these two will become complex. You see it? Potentially will start becoming complex. They'll break here and they'll become complex. Alright, now look at this. On the real axis. Now this is for your next test and your final. There will be at least one major problem on this. Okay, you need to understand how to sketch this.
You said next test is Tuesday?
Next test is Tuesday.
Okay, so we're going to be able to see the grades Thursday for the...
Yes, you'll be able to see it this Thursday.
And you have homework put out?
Yeah, I'll do that. So how do you plot it? Okay. The root locus exists to the left of an odd number of real axis. Odd number of, so how many poles go from here to here, okay? Do you see any root locus in between these two? These branches are root locus, okay?
No.
Do you see any root locus between these two?
No.
Do you see any root locus between these two?
Yes.
Do you see any here?
No.
Do you see any here?
Yes.
Okay. So the rule states that the root locus will exist to the left. How many poles and zeros are there on that side?
No.
Look at my hand. Look at this, okay? How many poles and zeros are there on the right?
1.
How many here?
2.
How many here? How many here?
3.
Count roots and count poles and zeros. 4. 1, right?
Yeah.
2, 3, 4, 5. Okay. So root locus only exists to the left of odd. Left of odd. Odd number of poles and zeros.
Yeah, I see.
This root locus is left of odd, right? Odd number of poles and zeros. This root locus, this part of the root locus. There is no root locus here because this will be left of even number of poles and zeros. You see it? How many? There are 2, right? So this region is what? Left of?
It's left of the 0.
It is left of even. This is left of?
You're pointing at the
This is left of even and this is left of odd. Left of even number of poles. Left of, if you look at left, this region is left of, there's nothing here, okay? This region is left of odd number of poles and zeros. Does that make sense?
But there's 4 of them. If you include the one, if you don't include one on the right.
No.
I'm what you're saying. You come out the S, the whole list, at the JW.
See this, okay? What region is this? How many poles do you see?
1.
How many, what is the region, what is this region? Can you say this region is left of 1?
It's to the left of 1?
Hmm.
No.
It is.
How's it to the left? It's to the right.
Left.
He's saying if you were at the
Which
The
one?
region is left of,
Okay, you're talking about the region, you're not talking about the actual.
yeah, the region is left of odd number of poles, right? Poles and zeros.
The region is to the left. The actual pole is to the right.
Don't worry about the pole. The region. It says region, right? Finite exists to the left of an odd number of real axis fine this thing, okay? What is this region? It is still left, right? But how many? What is the number of poles and zeros?
That's to the left or to the right?
To the left. This region, guys, pay attention here. This region, I'm talking about this region. Alright? I'm covered. This region is to the left of how many poles and zeros?
I mean, you got them covered. Right?
Two. No.
How many can you see?
2.
Victorious.
Right.
That region right there,
Hmm.
that the right side of your paper touches, is to the left of 2 poles,
2 poles, right?
and 2 is an even number.
2 is, so there is, it does not exist there.
That's why there's no region.
There is no root locus there.
Yeah.
Does that make sense?
I still understand it. I mean, I'm just getting confused on what region you're talking about. 'Cause I mean, what's the
We are only talking about this, okay? I've covered for, don't look at covered.
Okay.
We are talking about this region.
All right, I got you.
This region is to the left of what? How many number of poles and zeros?
2.
Even, right? 2 is even.
All right.
Okay. What is this region? Now.
To the left of it?
Hmm.
It'd be 3.
3, right? So it is left of 3 poles and zeros. This region.
Okay.
This region is left of 2 poles and zeros. This region is left of 1 pole and 0. Does that make sense? Julian? No?
No, I got it. I understand a different way. Yeah, I got it.
Bakari?
Yes, sir.
This region. Look at these regions, okay? These are regions between poles and zeros. There are 1, 2, 3, 4, 5 regions.
Well, I'm saying, what do we need? What is that step? How does that satisfy that rule?
So the root locus exists to the left of odd number of poles and zeros. So if you see this region, there is no root locus here. Right? This region, is there a root locus here?
Yes.
Yes. Is there a root locus here?
Yes.
Is there a root locus here?
Yes.
So you're saying there's an odd number of
Poles and zeros.
from those regions.
The root locus will exist only to the left of odd number of poles and zeros.
Can we do one of them?
Hmm?
Can we do one of them?
Did that? This is the root locus, right?
Yeah, that's 3.
That is 3. So to the left, it exists to the left of 1, 2, 3.
Hi,
Yes.
excuse me, guys. Do you have a key to 114 or 112? Bruce, or that one across the hallway?
Yes, it's in my vehicle. I can.
No, I don't need to come up there. I have to go to get mine. I thought you had it on. I'll find a way, don't worry.
All right. Okay. So that is, if I just draw this, okay, and I give you where will the root locus exist?
You draw a branch.
Hmm?
You draw a branch.
You can tell me if it exists or not.
Oh,
Right?
it's that first pole right there? Where's
Root locus will exist here.
Yes, sir.
This is possible here,
Nope.
here.
Yes, sir. Possible.
You got it?
I don't got it.
Huh?
That pole where it's at the 0.
You're saying based on you touched on working the rule backwards. That's what you're saying. But you I mean,
I'm just saying exists. I'm not saying exact. Does it exist here?
based on that rule.
Based on that rule.
Well, yeah.
Okay. Does it exist here? Does it exist here? Okay. So even without doing this, I can say the root locus will look like this.
But what if there's like an asymptote?
Hmm?
Is there always gonna be an asymptote like that right there? Oh, are you going? How do you know it's going like that?
Hmm?
How do you know it's gonna look like that?
It's probably going to look like this, or it's going to look.
So why can't
Like
it just be like? Why can't it just be another arrow going this way?
Hmm?
Why can't it just be another arrow starting at the pole and going to the next pole, like the last
This one?
Yeah, yeah. Why can't it be like that?
It does not exist there.
No, I mean like at the one it does exist at. Why does it have to be like one with an asymptote? Why can't it just?
So you here what? How many? What is the asymptote angles? Theta A would be what?
Oh, never mind. My bad. You're going based off of that. I thought you
Zero.
were saying if you just saw one, like a general. You know what I'm saying?
Yeah. You can calculate the asymptotes. Here it will be again 0, right? This will still apply. So 2. The number of this will be 3 minus 1, 2. So it will actually be 90 degrees. The first will be 90 degrees. The second, it will go like this.
Oh. Okay. Cool.
Okay.
So one always goes. How do you know? You see how on that graph over there.
Hmm.
See the one to the most left goes to the right, and the one from the right goes to the left. You see what I'm saying? Oh, that yeah. So you see how that where it's at -1, how it goes to the right and goes up. Kinda
Yeah,
goes-
so it follows these asymptotes are essentially this. It will follow this. It will meet at infinity. The angles will provide a direction to it.
Okay.
Okay, so here if the angles will be like this. This is one angle, this is second angle, and this will be third angle.
But why couldn't they be opposite directions? Like why couldn't the one to the left go up and be?
That depends. I mean, as long as you draw this, if you really have to figure out, then you have to do the plot. But you can say that is the root locus. So here you can say, you can conclude that the system will never be unstable.
Okay.
Okay. This is a graphical way of plotting this without really doing the table. All right. So let's do a quick exercise. Let's see if you guys can plot root locus based on your this thing. Okay. Pull out paper and pencil.
Ooh. No, you did.
I'll give you the poles and zeros. Let's see if you can plot.
Merry Christmas.
Wow. There's cake in there. Chill on, bro. What kind of cake is that?
How will the root locus look like here?
It would just go straight to that. Right.
What is the first?
Would it be from the S to the 0?
Yeah, that's all. You got it? What will the root locus look like here?
It'll
The one on the left, the X on the left would go towards the 0,
Correct.
and then the one on the right would
Will root locus exist here?
No.
It won't exist here.
Because it'd be 2.
It will be 2. Yes.
So it has to be to the S to the S.
So the ones in between the two X's are probably like asymptotes, like they probably go over or down or something.
Huh?
The ones like in between the two first poles are probably like asymptotes.
Right. So here, what you're going to see is, I'm going to show you. Okay. This is an interesting thing. Where does a root locus start? So where does a root locus start and end here? Look at the start and end points. Rule number 2.
Rule number 2.
Not 2. 4. Starting and end points.
You have that little.
Rule number 4 is, you say what it says? Like read it out.
Read it out loud.
Where does the root locus begin, 0 gain, and end infinite gain? The answer to this question will enable us to expand the sketch of the root locus.
Julian, just read the rule.
Yeah, that's what it says when I'm full.
Now go to the next page. The rule is in italics.
The root locus begins as a finite and infinite poles of GS, HS, and ends at finite and infinite zeros of GH and HS.
So it essentially begins at pole and ends at 0. Alright. So you can see, does this root locus begin at pole and end at 0? Does it begin at 0? Does it begin at pole?
Yeah.
Yes.
There is an infinite 0 somewhere here. It goes there. You get it?
Yes.
Here, there are how many infinite zeros do you see here?
2.
3 infinite zeros. Okay. 1, 2.
Oh.
So how many ever poles are there? Number of poles minus number of zeros. Those will be the number of infinite
Zeros. Or
zeros. Yeah, correct. So here, how many infinite zeros will be here?
2. Or no, sorry, 1.
1. Okay. So if you look at the root locus here, it will look something like this.
I get the flux.
Right. What do you mean?
I'm,
You lost
The root
it.
locus exists here.
What's the rule again? Can you say the rule one more time?
I'll tell you. The root locus exists here.
yes.
Does it exist here?
No.
Does it exist here?
Yes.
Does it? So look at the rule 1. What does the rule 1 say? Number of branches, right?
Yeah.
Number of branches of the root locus equals the number of closed loop poles.
How many closed loop poles are there?
Say it again.
How many poles do you see here?
Poles, I see two.
Yeah, 2. How many branches do you see?
I see 2.
2 branches. Okay. This is the first branch.
Yes.
This is the second branch. So that is satisfied. What is the second one? Symmetry.
It might
The
be
root
symmetrical.
locus is symmetrical about the real axis.
So it is symmetrical. Okay.
Oh, wait, do that, Dr. Sanders.
But you can
Oh,
think
now-
about
now
this as
it makes
symmetrical.
more
Okay.
sense.
That's not symmetrical.
That is symmetrical.
It's strong scale.
That I'm saying either way they won't land on top of each
It
other.
will land.
You're
If you
too-
close it, this will land on this. It will be a mirror. Okay.
Symmetric.
So here,
Don't think
Think
about,
about
it as
this.
drawing. Just think.
think about this, guys.
It's a poor
Focus
drawing.
on this. Please focus. Julian, you're going to lose your attendance today. Okay. Think about this. Okay. Rule 1 satisfied. Rule 2 satisfied.
Rule.
Roll through that class.
Was
Symmetry.
I'm gonna talk to the current for 45 minutes.
Sorry. You want me to?
okay, say yes or
Can you
no.
please pay attention?
2 symmetrical.
So rule one
I just
is
missed that one.
That is symmetrical for simple functionality.
rule one is symmetry.
The one was
No.
branches equal to
No.
Okay, somebody say something. Rule
2
one
branches, 2 poles.
is
Okay.
Rule
Symmetry.
one-
Do you see symmetry?
Yes.
Yes.
That's rule. I'm writing
Does
it
this
down.
rule? This is rule 3, right?
Yes, 3 words too.
Yeah, symmetry.
Does it satisfy?
Yep.
Does 4 satisfy?
4 is, but wasn't
The 4 is the root
Standing
locus
in
begins at the finite and infinite poles of g of s times h of s, and ends at the finite and infinite zeros of g of s times h of s.
Okay.
Yeah,
So you can
poles
see
and
that
zero.
it starts at pole and it ends at, this one ends at a finite pole, this one ends at an infinite pole, infinite 0, sorry. This ends at a finite 0, starts at a finite pole, ends at a finite 0. This one starts at a finite pole and ends at an infinite 0.
So yes.
But, I mean, never mind.
Do you want me to read?
No, I got
Yeah,
you.
I want you to read it.
Okay.
Can't read it.
Yeah, I can read it again.
No, we got
Alright.
So what do you want?
I'm gonna read it.
So now you want me to read it
Yeah,
again?
I don't want him to read it.
Okay.
I'm
The
gonna
root locus begins at the finite and infinite poles of g of s times h of s, and ends at the finite and infinite poles of g of s times h of s.
Got it? Okay. Now if I do this, if I change this to,
I was just didn't know. I was trying to make sure. I listened. He said it begins at the finite and close.
Is this system, can this system be unstable?
Yep, it can be unstable.
No.
Unless it's to the right, unless it's to the left of the graph.
This one, you just did.
Oh no, it's stable.
It cannot, right? Because everything is going to the left. Only that system is unstable.
Yeah, for a little bit.
There's
Okay.
a point at which
So here, I'm going to look at another one. Tell me, how will this end? How will this root locus look like?
oh, okay.
I
I was
think it's
trying to,
weird that I knew how to do that.
Hmm?
I think it's weird that I knew that that was
cool
gonna
story, bro.
Thank
Yeah.
you.
Got it?
Yeah.
Wow.
So, will this system be unstable?
Wow.
Can this system be
Y'all are
unstable?
good.
No.
No.
Wow.
Y'all suck, man.
Let's see about the test right
Yeah. We will.
The next test, because that's what this is on.
Yeah.
Is it
Next Tuesday?
How will this root locus look like?
You got one.
Can you let Adrian draw it? Because he said he knew how to draw it.
No, I just need the last one. This one looks weird.
Oh, okay.
Well, I mean, it's because one of them is going to start
This
at
is
the
the
pole and go
first
to the other pole.
Root locus will exist here, right?
Wow.
Yes.
It won't exist here, right?
Nah.
So here this will look like, so you have 3 minus 1, right? 2.
Mmm.
It's gonna have a little line.
Oh, yeah.
You need another branch.
These are the branches.
Or you consider another branch. Okay.
So how many branches are there?
3.
How many poles are there?
3.
3.
Symmetrical.
It is symmetrical? Right.
Mm.
Cool. And you knew that one too, didn't you? I bet you did.
They do another. Yeah. Yes, sir.
Let me not do. How will this look like?
Okay. So
Could one of us?
you're gonna have a line.
I'm saying that the one on the left is gonna. There's gonna be a line. Yes.
Yeah, there.
And then the line that's gonna be left.
Yeah, it's your birthday. But we ate the cake before you.
Got it?
So could we do one that we like you just had with the two
I'll discuss that.
I'm
Okay?
gonna say happy birthday, not birthday.
Bro, it is his birthday.
I'll tell him that. I just didn't want
How will this root locus look like?
the one on the far left?
You need 3 branches, I know that.
Hmm?
You need 3 branches.
Yes, so but how will this root locus look like?
Should I drop?
Oh.
he taking it this year. That's crazy.
It might not satisfy number. You need a 0 though, don't you? It might not satisfy rule number 1.
So it is all the roots are poles are going. All the branches are going to
Infinite 0.
infinite zero. Yes.
But you don't you have to draw that though.
The infinite zeros are infinite. They are not within this. So all these you can see they are infinite zeros.
So you can give us something like that on the test without a 0, and we'll have to say that it needs to be infinite.
Yeah, it's easy.
Is that
Simple.
right?
Yeah.
That's a trick
The
question.
only thing is it's closed. It will be like this.
Come on, Tony.
It's simply because your theta is what? It is pi by 3. It will follow this.
Okay.
Pi by 3, pi minus pi by 3. Here it is like this because theta will follow
5 pi over 2. 3.
first will be pi
Over 3.
over 2,
Oh yeah.
right?
Yeah.
Here it will be, next will be pi. And the second one will be pi minus pi over 2. So that is the reason it will go.
Well, what about that one right there? That one.
This one,
Yeah.
it will be pi by 3 because there are 3, right? This essentially the denominator is 3.
Okay.
There is no finite 0,
Yeah,
so it
but-
will be 3. So it will
Okay.
be pi by 3, pi minus pi by 3. Here it will be pi, that's it.
Okay. Wait.
Okay, that makes sense.
Yeah, because there's one finite pole and one finite 0.
So
Gotcha.
it will be 2 minus 1 here, right?
Oh, that's a subtraction symbol.
Yeah.
Okay, never mind.
Number of finite poles minus number of finite zeros. It will be 2 minus 1, it will be
So
1.
these values, these directions, are going to depend on
But
Yes.
so X is finite, but the zero is going to infinite though. It's going to infinite zero.
Right.
But that pole.
There is one finite. So you think about how many infinite zeros or poles you're going to have. If there are equal number of poles and zeros, okay, there will be no infinite zeros or poles. Does that make sense? Got it?
No infinite right
No
there.
infinite, right? If you have this, tell me where.
Oh, that you won't have an infinite zero.
Infinite pole.
Yeah. No.
So what you'll do is you'll do this, but your arrow will be like this. It's coming from infinite pole.
Could I might have to
Is that like a limit?
talk to you about that one.
Here, see, if this was a pole, it would go the other way. It is going to an infinite zero. The root locus is from pole to 0, right? So you can see pole to 0, right? If this becomes a 0,
It has to come from an infinite
it has to come from a pole
cool.
to 0.
So I'll ask you after class.
Good.
So this will be your test 3, okay?
Is the homework online? Is it on Blackboard?
I'll put it
it's
up
not.
on.
Okay. Sorry, I just wanted to hound him about it.
You don't listen, class. So
No,
that
Torius,
way.
I pay attention. We're gonna be YouTube